Say we want to determine the equation of the normal at x is equal to x is equal to 1, to f of x is equal to negative 4x cubed plus 3x plus square root x minus 2. To find a normal, first we need to find the tangent. So a normal is any line that is perpendicular to another line. Okay, so let's find the slope of the tangent, and we know that perpendicular slopes are negative reciprocals. Alright, so the slope of the tangent is going to be the derivative function at a certain point, right? So we're going to find the slope of the tangent at x is equal to 1. So that equivalent expression here is basically f prime of 1. Okay, so let's find our derivative function. So f prime of x, actually before we find our derivative function, let's simplify f of x and make it purely exponents. Okay, so you have negative 4x cubed plus, you can use the reciprocal rule, right? So 3 times x to the power negative 1 plus square root of x you can write as x to the power 1/2 minus 2. Right, so the first derivative f prime of x is equal to the derivative of each of these terms, derivative of negative 4x cubed plus 3 derivative of x to the power negative 1 plus the derivative of x to the power 1/2 minus the derivative of 2. Okay? So the derivative of negative 4x cubed is basically, you're just using the power rule here. So f prime of x is equal to negative 4 times 3, negative 12x squared, right? Plus negative 1 times 3, so minus 3 x to the power negative 2 plus 1/2 x to the power negative 1/2 minus, well, this is 0, right? Derivative of any constant is 0, so we don't actually have to write that. So we'll leave it like that. And now we can basically simplify this, just positive exponents, right? So we have negative 12x squared minus 3 over x squared plus 1/2 x to the power 1/2. Okay? We want to find the equation of the normal at x is equal to 1 to this function, right? Well, the normal is going to have basically negative reciprocal slope, right? So first let's find the slope of the tangent at x is equal to 1. So f prime of 1 here is negative 12 1 squared minus 3 1 squared over 1 squared plus 1 over 2 square root 1, right? X to the power 1/2 is square root x. And if we crunch this out, we get negative 12 minus 3 plus 1 over square root 2. Okay, so let's do 2. And in this case, what you're going to get here is f prime of 1 is equal to negative 15 plus 1/2, which is equal to negative 14.5. Okay, so, or you can change this as basically a fraction. You can write this as like negative 29 over 2. The slope of the normal is going to basically be 2 over 29. Okay, you want to find the equation of the normal. Well, when we're looking at equations of a line, we're basically looking at y is equal to mx plus b. We have the slope down here, so y here is equal to 2 over 29 x plus b. And now what we need to do is to solve for the y-intercept, we just need to substitute any point that lies on the line, right? Because any point that lies on the line will satisfy the equation of the line. So we want to find the equivalent of x is equal to 1 in terms of the y value in this equation. So let's figure out what f of 1 here is. F of 1 is negative 4 times 1 cubed plus 3 over 1 plus square root 1 minus 2, which is basically negative 4 plus 3 plus minus 1, right? Plus 1, let's just do plus 1 minus 2, right? So you get basically f of 1 can basically be equal to negative 4 plus 3, which is negative 1, plus 1, which is 0, minus 2 is negative 2. Okay, so 1 and negative 2 exist. Note here that you can't have two possible values that exist at the same time for this function because of the fact that it would not be considered a function, so I'll just take the positive value. And then we have this point. I'm going to substitute this point, 1 and negative 2, into my equation. So y is equal to 2 over 29 x plus b. I'm going to sub in negative 2 for y, 1 for x, and in this case you get b is equal to negative 2 minus 2 over 29, which is basically negative 60 over 29. Okay, so the equation, I'm just going to write the answer here, but y is equal to 2 over 29 x minus 60 over 29. And that's the idea.